Welcome to Walk About the Galaxy, the just-in-time astronomy podcast, where the science is universal, the opinions are personal, and the mood is TGI Friday-ale.
Ooh.
We are
What are we just in time for?
Huh? What is it just
What are we
in
just
time?
in time for?
Anything.
We're just in time for the podcast.
Okay. All right. Go ahead. Sorry.
I don't know.
I was confused.
Yeah. We are Strange, Charm, and Top, the Astroquarks, also known as Josh Caldwell,
Addie Dove.
And Jim Cooney.
coming to you from our respective home studios where Jim needs to turn his volume up, I think.
And where we have a special guest of Mr. Darcy today.
Yeah. For those of you watching on YouTube, we have a special guest of Mr. Darcy. If you're not watching on YouTube now, aren't you really intrigued and you want to go totally check that out? Our stumpers today are escapist. It's a good time for escapism. And the cat is Mr. Darcy. Oops, I let the cat out of the bag. Jim.
Yeah.
Beta Omicron Delta 3 or Risa?
I'm going to go with Risa for two compelling reasons. Compelling reason number one, Risa was on Star Trek The Next Generation, which was my Star Trek. I don't think that other one was. I think I only recognize that from like one episode of the original series, so I don't even know.
Yeah, Beta Omicron Delta 3 is also known as the shore leave planet. It's
Right.
almost never known as Beta Omicron Delta 3. I think it's not known by anybody at all by that, including the people who made that show. But that was the episode shore leave of the original series.
Right. So my understanding was that.
Risa.
What's that? Yeah, right. So the thing is, I thought that Beta Omicron, well, the shore leave planet was all about like simulations of whatever the heck you wanted, and Risa is like real folks. It's just they've like controlled the weather. It's nice beaches, and the population is overly sexual. And so Risa seems like a great place to be because I think that
because you're overly sexual.
Well, not necessarily. I'm regularly sexual, but but I prefer the real thing to like simulation. Like I wouldn't like the holodeck or anything like that. I don't want because part of the enjoyment of a thing is that it's like real or like, you know, like that's why like a strip club or something is not that great because they don't care about you or something like that. Or, you know, I mean, you want.
I'll have to take your word for it.
I don't know. Yeah, this is all secondhand, but like, I don't know. Seems like the real thing, even if it's not perfect, is better than the perfect simulated thing from my perspective.
Okay, so Rise, you're going to go with the Star Trek Next Generation Pleasure Planet, which is sort of like, what's the name of those places in the Caribbean, the sort of adult resorts? What's it called?
Yeah.
And aren't there some sort of like adults only vacation resorts in the Caribbean that are a little bit risque?
I think I know what you're talking about, but I can't remember the name of those things. But yeah.
Yeah.
So, yeah. A little bit like that.
And shore leave would be sort of like going to Disney World. I mean, that's make believe too, but it can also be a lot of fun.
I hate Disney World, but yeah.
Have you been there?
Yeah.
Well,
yeah, it's just that's mostly just because it's too many people. But I guess if it were empty, it would be fun.
Oh yeah.
Yeah.
Well, it's empty now.
Womp womp.
But it's a lot of fun. But thanks. There goes our great Disney World sponsor. So much for those millions of dollars they were going to send us. Addie, same general idea, different universe. Naboo or Endor?
I'm gonna go with Endor.
Okay.
First of all, I'm in the camp that enjoys the Ewoks.
Oh.
Yeah.
Also, I love a good moon. So.
Okay.
Endor is actually a moon, right?
Right.
So I'm gonna go with Endor. It's I like it. It's good. It's got good. They have all those tree houses. It's a big forest planet.
Yeah.
I don't know. I love a good tree house. I would love to live there. It seems amazing. Naboo, sure, seems fine. It's a nice civilized place, but meh.
Yeah. You might run into a whatever Jar Jar is though.
A Gungan.
On Naboo. What's he called?
A Gungan.
A Gungan, that's right. Yeah. Okay, so Addie's going with Endor, the forested moon of what's here, spot flash trivia. What's the name of the planet that Endor orbits?
Or wait, is Endor the planet and the thing that Ewoks live on is the forest moon of Endor? Or that's like a different planet? It's the
I think
forest moon
Endor
of
is the
Endor.
moon, and
Okay.
it's in Star Wars Return of the Jedi with the Ewoks, and I think it orbits something called Yavin, maybe.
Oh, maybe.
Yeah. Okay.
I'll buy it.
Jim is clueless. Well, anyway, today
Oh no,
we're
it
going.
orbits the outer rim planet of the same name.
What?
What? You can't name the planet and the moon the same thing.
Yeah, that's
Sorry.
ridiculous. That's not allowed.
I'm not mad at you, Addie.
I think
I know.
we're gonna have to reject your choice if
I'm
Endor is
looking at
named.
Wikipedia. I'm looking at Wikipedia right now, and it says that it orbits. It's in the Endor system. It orbits the planet Endor. Two suns, Endor 1 and Endor 2.
Oh,
This is the
great.
worst naming convention for a planetary
Yeah.
system ever.
So it's got two suns. They're both called Endor. There's a planet orbiting the two Endor suns called Endor, and there's a moon orbiting the planet Endor called Endor.
Yep.
Solid.
All right. Well, today we'll talk about the wispiest of particles, neutrinos, and what they may tell us about why you exist, and a nearly Earth-sized exoplanet that may be in the habitable zone of a nearby star. NASA has set a date for the first launch of US astronauts on a US rocket since 2011. And another episode of Walkabout the Galaxy is here, which means there's probably another launch of 60 Starlink satellites to announce. So we'll talk about that. But first,
Reasonable.
this episode of Walkabout the Galaxy is brought to you by Libration. Are you a moon who's feeling locked into a tidally synchronized spin in orbit? Wish you could just once turn your back on that smug planet you've been circling for billions of years? Libration may not be able to offer you liberation from your gravitational bind, but libration can almost set you free. All you need is a bit of orbital eccentricity to let you race ahead or hang back so you can thumb your nose at that stuck-up planet, or at least have your nose not pointing right at it for a bit. So crack out some libations and celebrate your synchronous rotational liberation with libration. Libration, a little dab will do ya.
Nice. Okay.
A little dab will
Yeah.
do ya. Any takers?
Yes. That is it a cologne? No. No, it's a lotion.
It's in that general category of things that you dab on yourself. But you don't dab it on your face or your
Is it a hair
body.
thing?
You dab it in your hair.
Yeah.
This is before your time, Addie. Brill cream.
That's what it is. I know it because of a Jimmy Buffett song, I think, actually.
Oh, okay. Yeah,
I
anyway,
think.
that goes back to the 50s, Brill cream. A little dab will do you. And libration, of course, just being the little wobble that the moon does. We have the same face facing us all the time, but not quite exactly the same all the time. It
I think that there's a song called Pencil Thin Mustache by Jimmy Buffett in which he sings about Brill cream.
Really?
Yes.
I know that song. I don't know if, yeah.
Well, Brill cream would make sense
I'm gonna look up the
for
lyrics.
a pencil thin mustache. And we almost had a musical trivia today, and that would have been a fun tie-in with that, but I didn't know about that connection to Brill cream.
It's one of the last lines of the song is, yeah, Brill cream, a little dab will do ya.
That's awesome.
That's why I knew that. That's why I knew that phrase.
That was in your brain there. That's
is.
hilarious. Well, anyway, our trivia is not musical. Our trivia is going to be galactic, but we'll come to that a little bit later. So yeah, we have space news. We mentioned that NASA has just announced a target launch date for Crew Dragon.
Yeah, May 27.
That's coming up soon.
I know.
Depending on when you listen to this, maybe even sooner, or definitely even sooner. But for us, we're recording this on what,
April something.
17th or something like
17th.
that. So yeah, that's less just more than a month away.
Yeah, it's pretty
And so
exciting.
how many astronauts are going on this, Addie? 2 or 4?
Yes.
Okay.
I thought it was
And
4, but then I was reading something else and decided it was maybe only 2. I think it is only just the original 2. So it must be the second one where they're sending 4 or something. I don't know.
so 2 astronauts just came home overnight on a Sputnik landing in Kazakhstan. 3 astronauts, sorry. Well, 1
Well,
cosmonaut, I guess,
one
and 2
cosmonaut.
astronauts. But
Yeah.
two American astronauts came home on a Soyuz, including Jessica
Mir.
Meir.
Mm-hmm.
Uh, and so they've come down from the
Andrew
International
Morgan.
Space Station, and then we'll have 2 Americans going up on the first sort of operational flight of the Crew Dragon capsule, which is launched on a SpaceX Falcon 9. And, they've been launching Falcon 9s for years, and they've been launching crew capsules for years, but it's taken a while to get to this point because of all the extra certifications and some additional technology that's required to make it so that there's extra safety because there are people on board, so that they've got a way to safely escape if there's a problem with the rocket and so forth. So that's targeted for May 27th. So that'll be a big milestone for sure. I
Yep.
remember years ago, after the shuttle program was just sort of had recently ended, and at that time, people, including myself, were saying, oh, well, we'll be launching US astronauts on US rockets in 2016 or something like that. And I should know better by now that, never to trust a launch date that's years in advance, because you can
Yeah.
multiply that by 2.
Yeah.
Yeah, next, speaking of
They're
SpaceX,
supposed to
next,
do
go ahead.
1 additional parachute test. I think they're going to do 1 more parachute test. SpaceX is before they do the final, before they actually do the launch. Because
Okay,
that's one of the they've had some issues off and on, and mostly it's been working, but they've had some issues off and on. So they have 1 more test they're going to do before that.
yeah, you don't want your parachutes to not work.
Yeah, you don't want to get to space successfully, be coming back just fine, and then your parachutes don't quite work.
Yeah.
Oh.
Yeah. Speaking of problems with manned spaceflight or human spaceflight, we're recording this in the week of the 50th anniversary of the Apollo 13 mission.
Mm-hmm.
And so there have been a lot of stories about that, and you can kind of read along. And I was reading through some of the transcripts of the mission. It's a long time, it's days. They're stuck in this little tiny, tiny, tiny space with very little power, not enough water, and not entirely sure how things are going to work to get home. But one of the things that I didn't know was the famous line, of course, from that mission is,
Houston, we've had a problem.
yeah, so that's the right line.
I know.
But I, for my whole life, had been hearing and saying, Houston, we have a problem.
Yeah, I mean,
But
that's what's printed on everything.
yeah, but it was actually, Houston, we've had a problem.
Yeah, it's like we've had a problem up here in something.
Yeah,
There's like
when
an
you read the
additional part of it.
transcripts, there's no sense of urgency. Like the transcripts is always a lot of joking and kidding and very conversational. You don't really get any of that sort of sense of this is a life and death situation, and we don't know how we're going to get out of it.
It seems like
That was 50 years ago.
we have a problem is more apt than we've had a problem. We've had a problem might mean it's been solved. We currently have a problem is more appropriate, probably.
Yeah,
Well,
I
they
mean, I think
didn't.
in context, it's like we've had a problem with such and such sensor or something like that is like the full thing. So it like makes sense in context, but yeah, if you're going to take it out of context, it's better to just say we have a problem or something.
Yeah, but at the time they weren't entirely sure what had happened.
Yeah, they just their sensors were reading off and like on the tanks, and they didn't know what it was and stuff like that. So
something
there's
had
a
happened.
cool website called Apollo in Real Time that was put together back a little while ago for the Apollo 11 mission, but they've done it for a bunch of the different ones now. And so like during the anniversary of when that mission happened, they sort of in real time play the transcripts, both from mission control and from the capsule, and they have like mission events and stuff like that, so you can follow along for how it happens. That one launched on my birthday, except I wasn't born yet.
Right. So you were born on the anniversary of the Apollo 13 launch.
Yes.
Other space news, we've been tracking the progress of the mission OSIRIS-REx, which is orbiting this little tiny asteroid called Bennu. And coming up this summer, it's supposed to go down to the surface and use this long, although not really that long, but this sort of 2-meter arm with a thing at the end called tag SAM. For
touch and go sampling mechanism.
Oh, cool. I'm glad
Nice.
you knew that. To pick up to maybe a couple of pounds of particles off the surface of the asteroid and put in a little sub-spacecraft, which will then come back to the Earth in a couple of years. So they been a lot of excitement over the last year because the asteroid surface is so rough and uneven. They're like, where are we going to go to get in there? So they just did a test rehearsal or a dress rehearsal.
Yeah, it was a rehearsal of the descent and then coming back away from the surface. So they went partially down to the surface, and then sort of like turned around and came back up just to show that they could sort of do the correct navigation, terrain feature recognition, stuff like that, tracking, and then turn around and back away from
how close did they get to the surface?
They got, well, so I actually asked my class this the other day. I showed them the video and then I asked them how close they thought the thing got to the surface. And if you look at it, it's really weird because it's basically like a fractal. It's messing with your mind. It's hard to tell what the scale actually is. And so they all guessed like a few feet, but it was actually like 200 feet. So unless you know the size of like the boulders on the surface, it could be something that's like centimeters in size, or it could be something that's tens of meters in size.
That's why you should always have scale bars on your diagrams. You know, if you're showing a picture to a class or anything. I was actually the same way
not if you're trying to make the point that
no, of course when Addie's doing it, trying to get of course, but I've seen so many. When I first saw that very same footage that you're talking about, Zoe was showing it to me. Then I was looking at it, and I also thought that's a few feet because because I had no idea that those boulders you were looking at were 10-meter boulders, or something like that, big, giant things, rather than scale bars, folks.
Yes, very important.
Yeah, I would have been the same with you guys and with the class. I thought it was like, wow, it actually went down to the surface, and I'm still astonished that it was that far away.
Yeah. I mean, it seems to me if you're testing the thing, you would have gotten a little closer. Maybe not as close as you're going to get when you actually collect the stuff, but I mean, how good a test is it to go 200 feet away when you actually have to go a foot away when you do the thing?
I mean, I think they're going to do one more rehearsal before they do the actual thing.
And get closer?
And it's definitely useful to make sure that, so part of what they were testing, right, is like that their sensors work the way they think they do and that they can get the real-time feedback that they need and stuff like that. So like some approach is much better than nothing at that point, and so they still get a lot of what they needed, I think.
Yeah, I mean, you're testing, this was all done autonomously by the spacecraft.
Yeah.
So you're testing that that the sequence works, like that it can maneuver towards the surface and then stop maneuvering towards the surface where you want it to and back off safely. So, things could have gone wrong, but there's a very, very cool, is it GIF or GIF? GIF. There's a very cool GIF where you see the tag SAM arm in the foreground as it goes down towards the surface. And we'll post that on all of our various platforms, but it's super cool. And just as you say, it looks like you're very close, and that's partly because I guess there's no erosion, there's no like earthly erosion on the surface of this, where big things on the Earth tend to get smoothed by rain and wind and those sorts of things. And so these big things are super, super rough and crinkly edged. And those crinkly edges don't survive if they're, in an Earth-like environment. But you can have a very rough-edged boulder, I guess, on an asteroid and for a long time. So it's super disorienting and interesting looking. And exciting to see when they do that sample selection. We will tell you all about it, of course, on a future episode. So that's the space news I've got. Nerd news, we were talking about conventions.
Canceled?
Yeah, canceled.
Officially, MegaCon, which is the largest sci-fi convention in the Central Florida area, is just delayed from its normal May timeframe to June. But it is a pretty crowded sort of environment. And I don't know if that'll happen. And Comic-Con in San Diego, it normally happens in August, is a very large convention.
It's canceled.
It's been canceled for this year.
Yep.
Yeah.
Yeah, I've been thinking about all of our science Oh, go ahead.
I was just going to say, these things are unfortunate, but definitely the right call. COVID will still be here in August and June. And
I've been thinking about all of our conferences, like all of the ones we were supposed to have up through July at least have either been postponed or gone virtual. But I'm guessing like the big ones like AGU, I'm guessing is not going to happen in December.
AGU is this like a 30,000 person conference in December, and
what does that stand for?
American Geophysical
Union. And they have a smallish, it's mostly sort of Earth geophysical and atmospheric and oceanographic science, but they do have a planetary component, which is small part of AGU, but since AGU is so big, it's still a significant meeting for planetary science as well. But yeah, we'll see. They've been posting announcements saying they're planning for either an entirely virtual, a normal meeting, or some hybrid of the two.
Yeah.
So let's, we don't know exactly how that'll all pan out. So in any event, let me drop the trivia on you.
Oh.
Okay.
Before we hit our science topic, since we've talked about so much space news and other stuff. As I mentioned, it's galactic, and so we'll use that to segue in towards the neutrino story, because I don't know, it seems to fit
galaxies and
with
neutrinos are about the same scale. Yeah.
Neutrinos and galaxies go together better than neutrinos and planets, which is the other thing we're going to talk about.
Neutrinos and galaxies go together like, finish the sentence.
Right, yeah. Is that going to be on your final exam? So,
yeah.
We frequently have had trivia having to do with names of things, but they've generally been things like names of moons or names of features on planets or names of asteroids, which have some fanciful names. But that's primarily because planetary scientists just generally tend to do a lot more naming of things after people or characters or fanciful places in mythology than stellar and galactic astrophysicists. But before we had literally millions of galaxies to look at, some of the more notable ones got names. So I don't know if these have the sort of official imprimatur of the International Astronomical Union, but these are the names that these galaxies are known by. So for example, M31 is the Andromeda Galaxy. Okay, so it's names like that. I'm going to read you 6 galaxy names, and 5 of them are real.
Okay.
1 of them is not. Okay.
Okay.
So 5 of these are names of galaxies in the same sense that the Andromeda Galaxy is a name of M31. The Black Eye Galaxy, the Corona Galaxy, the Eye of Sauron, the Fireworks Galaxy, the Hockey Stick Galaxy, and the Sunflower Galaxy. So 5 of those are real galaxy names. There are about 50 galaxies that were bright enough before the sort of modern telescopic era that have names like that. 5 of those 6 are real. 1 of them isn't. So ponder that, but don't Google it. And let's talk about this new discovery of neutrinos. And we have to remind everybody, including me, what the heck a neutrino is.
Neutrinos are some of the wispiest of particles. They're these little wispy, meaning light. They have almost no mass. For a long time, we actually were not sure that they had mass at all, but we now do know that they do. But the mass of a neutrino is thousands of times smaller than the mass of an electron. We don't actually know what it is exactly, but we know that it's at least that. the trouble with neutrinos is that they're ubiquitous, they're everywhere, but they do not interact with other things very easily. So only 2 of the 4 fundamental forces in nature do they interact with, or do they act via. They interact via the weak nuclear force and via gravity. Gravity, not very strongly, because gravity is a very weak force to begin with and their mass is low. And the weak force is a force that you don't hear about very much because it's weak and it has a very short range. So it only, the weak force is only a thing that if you're really, really close, then it might interact. So that means that neutrinos, like right now, there's trillions of neutrinos piling through you and you have no idea.
I hate it every time you say that.
I know. But it seems upsetting, but of course it doesn't actually matter because they don't interact, right? They're just streaming through you, not interacting with any of your electrons or protons or anything else like this.
You're not what causes that thing when you're like, you have a chill and somebody says, oh, it's somebody walking over your grave. It's not actually neutrinos.
It might be.
Well, I'm so old that when I was a kid, we didn't know if neutrinos had a rest mass or not, but we do know that now?
Neutrinos have a mass, right? So we are sure that they have a mass, but it's not measured well. What we have measured well is the difference. So there are kind of 3 different kinds of neutrinos, and there are 3 different neutrino masses. Interestingly, those 3 different neutrino masses are not associated with the 3 different kinds of neutrinos.
What?
But I know it's not like, so the 3 different kinds of neutrinos, there's an electron neutrino, a tau neutrino, and a muon neutrino. And there are 3 different neutrino masses, but it's not like the electron neutrino has this mass and the tau neutrino has this mass and the muon neutrino has this mass. It's the electron neutrino has a superposition of those 3 masses. The tau neutrino has a different superposition of those 3 masses. It's an odd, complicated business, but
you're just making stuff up now.
I think, right? So we don't know those masses.
Now he's going to say he's not, and we're going to believe him.
We do know. So we do know the difference between the various masses, and we do have limits on how big the mass can be. We know it's not 0, and we know it's smaller than a certain amount, which is a couple thousand times less than an electron.
Does the superposition of masses happen on Risa?
On a good day. If you're looking for Jamaharon,
I don't know what that is.
You picked Ryzen, you don't know what Jamaharon is?
I don't know. I mean,
well, then I will have to 3D print you a Horgon then.
Oh my. Oh my.
All right.
I don't know
keep
if you're
it classy, guys.
Keep
it classy.
So if I'm worried about my weight, I can just say, well, this is actually just the superposition of my mass and 2 other people's masses.
There you go.
They've put on a bunch of weight, so it's not really my fault.
It's not your fault. That's right. Mm-hmm. But yeah, so these things are everywhere, and they're extremely important in all kinds of astrophysical processes that the sun produces. I mean, they're one of the byproducts of nuclear fusion in the sun. So one of the ways we tested our models of what was happening on the inside of the sun was by detecting neutrinos coming from the sun. Neutrinos are a huge part of supernovas and all these other things in astronomy and astrophysics. But we're interested here because neutrinos, just like protons and electrons, have antiparticles associated with them. And we have on the program before talked about the very lucky fact of nature that in the very, very early universe, there was ever so slightly more matter than antimatter, which led to a universe that's today made only of that little bit of extra matter. And we've been looking for a long time about clues for why this is, why there's a little bit more matter than antimatter, even though they should be totally symmetric. And we're starting to get some clues now by looking at neutrinos. So for every neutrino, there's an antineutrino. And so there's this experiment running in Japan. So Japan has this awesome neutrino detector called Super Kamiokande, where a neutrino detector is stupid hard to build because
it's the coolest thing in the world.
Yeah, it's amazing. So, they're so hard to detect because like we just said, they just go through everything. How do you build a detector to detect something that just goes through it? Well, they don't always go through everything. Every now and again, they get close enough to a thing to interact. And so you have to build a really big detector that so basically what super Kamiokande is this enormous vat of ultra pure water surrounded by all these photon detectors. And the idea is every now and again, most of the neutrinos just go right through it, but every now and again, one will interact with one of the particles in one of the water molecules. That will cause other particles to be produced, which produce light, and that light can be detected on the outside of the thing.
And this vat it's a big underground thing. It's like an old mine that's
exactly. It's an old mine filled in with 50,000 tons, which is like whatever, 100 million pounds of water, ultra pure water, which just every now and again a neutrino goes in there, knocks something off, causes that little something to move faster than the speed of light in the material, which causes this cool kind of
Cherenkov radiation.
Cherenkov radiation, exactly. And that is detectable because that's radiation, that's just light. So we have all these light detectors that can see that Cherenkov radiation. So what they're doing is, there's on another part of Japan, there's a proton accelerator, one of these particle accelerators. And one of the byproducts of smashing protons into other things is neutrinos and antineutrinos. And so they're producing a whole bunch of neutrinos there. 300 kilometers away at Super Kamiokande, they're detecting those neutrinos because they all basically make it right through, right? They just go right through the Earth and get to this neutrino detector. And so they're detecting the neutrinos and the antineutrinos that are being produced at this accelerator. And what they've noticed is a very slight asymmetry in what's happening with the neutrinos versus the antineutrinos.
Ooh.
And that is very exciting because it's that kind of asymmetry that we're looking for. So that it's that kind of, there needs to be some asymmetry between what happens with matter and what happens with antimatter in order for the universe to exist. So
right,
the very reason that we're here is because there's a light violation. And so we're finally starting to see footprints of that that asymmetry, which is very, very cool.
Okay. So,
awesome.
so if the universe had been started like completely 100% symmetric between matter and antimatter, in the early days, it all would have annihilated. There'd just be photons.
It would all have annihilated. It would all just be radiation, photons. Yeah, the whole universe would just be light.
We wouldn't be here. And so there's some asymmetry. And this is just saying, here is a natural thing that goes on with these little tiny particles that has an asymmetry between matter and antimatter. And maybe somehow that's at the root of why overall all the other matter in the universe has some kind of asymmetry.
Right, that's exactly right. So yeah, I mean the details are of course ludicrously complicated, but yeah, this is, we've wondered for very long how that asymmetry came to be, why there was an asymmetry, and so we want to understand it in terms of fundamental physics and fundamental particles, and this is helping us do that.
Okay, cool.
That's pretty cool.
Cool.
Yep.
I also learned that they're building an experiment, a neutrino detector experiment in South Dakota, right?
What? I did not know that. In some old abandoned mine or something?
Yeah, so it's called DUNE, the Deep Underground Neutrino Experiment. And so it's using an old mine, and it's near the Fermilab accelerator in Illinois, and then near this other Stanford underground research facility. So they'll have some detectors that are closer to Fermilab and some that are at this deep underground facility to be able to do similar measurements of like production and then change over a distance.
Right. Yeah, I think this is really cool. Like, I mean, the neutrino detectors were kind of built to detect neutrinos from, astronomical neutrinos from the sun or from supernovas and things like that. But you can also do like controlled experiments by making your own neutrinos at these particle accelerators and watching for them in your neutrino detectors. So neutrino detection is awesome. I'm shocked that it worked, because like an average neutrino will go through something like 1,000 light years worth of lead before it interacts randomly. Right. So you have to have a ludicrous number of them in order to detect any, but we do, because there are ludicrous numbers of them out there.
One of the first detections, I think, or at least first detections from a not from the sun, was from the supernova in 1987 in the Large Magellanic Cloud, and they detected like 11 neutrinos, I think, from that explosion. That was this huge breakthrough, the 11 of those uncounted numbers of neutrinos produced in that stellar explosion. Well, the last thing we want to mention, we frequently talk, in addition to frequently talking about matter and antimatter, One of our other favorite topics is the latest almost Earth
Woo!
discovery. So we have there's a new almost Earth discovery. This one is called Kepler 1649c.
Mm-hmm. Yeah, got a big number.
So the name Kepler means it was discovered by the Kepler spacecraft, which studied all these stars to look for transiting exoplanets. This particular one was originally like flagged as a candidate, but then said, no, we don't think it's real. But now in further analysis of the data, they've been able to follow up and confirm that it is in fact a planet. Its year is 19 and a half Earth days long. And the star, that's because, of course, it's around a smaller star than the sun.
Right.
As most of these are.
An M dwarf.
Right.
Yeah. So it turns out, of course, most stars are smaller than the sun. Not that the sun is atypically large, but the general size distribution of things, there are more small things than there are big things. And so there's lots and lots of small stars. So we're more likely to find habitable planets around small stars than we are big stars, just because there's more of them. Yeah,
and so even though it's much closer, right? It actually only gets about 74% of the same incident light that Earth gets.
So chilly, maybe.
So,
yeah. So it's technically in the habitable zone of this star, but whether or not it's got like liquid water and stuff like that, or life, would depend on all sorts of other things that we don't really know the answer to now, like whether it's got an atmosphere and that sort of thing. This star is 300 light years away, so just a hop, skip, and a 300 light year jump.
No problem.
Nearby.
Yeah.
Oh, it's got another inner planet that orbits at 8.7 days and is about the size of Venus.
Yeah, so this particular planet, in addition to being sort of in the star's habitable zone, it's the newest, most earthy because it's almost exactly the same size as the Earth.
Not because it has that sort of dirt smell.
It's an earthy, yes, it's got an earthy aroma. So right now, you know what the count of exoplanets is?
10,000.
Like actually, are we including Kepler candidates or like confirmed?
Confirmed.
7,005.
This story says just 4,100.
Okay, I thought that might be high. There's a lot of candidates, but I think that there aren't as many. I mean, this is only Kepler 1649, right? So they're
right. So yeah, there's a lot of potential ones that many of them probably are planets. So sometimes when you look at these numbers, they say, here's the number of exoplanets, but that's based on, like, we know that as it turns out, 90% of the ones that we say are candidates turn out to be real. So if you've got 10,000 candidates, you say 9,000 of those are real, plus the ones that you've confirmed are real. So it just depends on kind of what number you're looking at. But anyway, that's about 4,000 more than we knew when I was a kid.
Yeah.
We've learned a lot of things since I was a kid.
Neutrinos, exoplanets.
It's exciting, yeah.
Man, what you can learn in 6 months. That's crazy.
Right. All right. Do you guys want to take a crack at the galaxy names?
Yeah. I guess so.
Read them for us again.
Yes. The Black Eye Galaxy, the Corona Galaxy, the Eye of Sauron, the Fireworks Galaxy, the Hockey Stick Galaxy, and the Sunflower Galaxy.
So, like, I want to say the Eye of Sauron because it just seems like that can't be a name, but it's too obvious also.
Yeah, I was thinking the same thing. Like, that's too recent, and I mean, I know the books were a little further out than the movies, but still too recent. But
you know what I'm gonna do? You can do it's not phone a friend, but we'll do the 50-50, except it'll be the 1684, like in Who Wants to Be a Millionaire. Well, I'm going to eliminate the Eye of Sauron. It was on this list that I was looking at as a real thing, but obviously it's not in the same spirit as the others.
Okay.
It's a renaming or redubbing of something from when it was first seen.
I always think of Eye of Sauron when you look at
Those
Shoot, what's
planetary
the
nebula, yeah.
yeah, or the protoplanetary disk picture of
Oh yes, there's a
Beta
famous.
Pic
or something.
from Beta Pic.
Oh yeah.
Or no, Formalhaut maybe. Yeah.
Yeah.
One of those.
Fomalhaut is a star with an exoplanet that we've actually seen, and the picture of it has this big dust ring, and it looks like the ISR. But there's also a bunch of planetary nebulas that look like the ISR, that I've called that in my class, even though it's not the real thing. I've never heard of or seen the Eye of Sauron galaxy. I'll have to look that up.
Right, and lots of times those things look like the Eye of Sauron because of the arbitrary coloring scheme that astronomers put on their black and white pictures.
That's true.
Which are maybe frequently in infrared, and they just color it an orange glow
Reddish,
to make it look like the Eye of Sauron. Anyway, so I'm gonna remove that one from consideration. So,
okay. So
then the Black Eye Galaxy is, I've never heard of that one either.
What was the second one?
Black Eye, Corona, Fireworks, Hockey Stick, and Sunflower.
I'm gonna go with Fireworks.
It's actually the Corona Galaxy.
Oh, what? Really?
Yeah.
I really thought there was one.
I figured you made the question because you'd seen there was a Corona Galaxy.
Yeah.
You got us with your crazy psychology.
Yes. Don't try to out-psych strange. But yeah, it sounds like the name, it sounds like a good name for a galaxy because galaxies are sort of circular-ish and anyway, but no, there isn't one. But the Black Eye Galaxy is also sometimes called the Evil Eye Galaxy. And it just has a really, it's a spiral galaxy, and we're seeing it a little bit obliquely, and it has a really thick, prominent dust band on the near side. Well, probably all the way around, but on the near side, it really blocks out the lower part of that sort of lens shape of the galaxy. So it looks like somebody with a black eye. And there are some other funny ones like the Mice Galaxies and the Tadpole Galaxy and the Needle Galaxy and the Cigar Galaxy. So they're generally more fanciful, but then the astronomers are just like, screw it, Kepler 1649c. You know.
Yeah, right.
So, right.
Yeah, galaxies tend to be just letters and numbers, NGC, something, because there's just like ludicrous numbers of them. If you start naming them individual names, you're going to have to come up with a trillion individual names or whatever. So.
Right. Yeah. Same thing with stars. So and we're kind of getting that way with well, like with exoplanets, they're not getting names. They're just Kepler 1649c. But it's also getting that way with like features in the solar system. We're sending spacecraft, and it's like, oh, we landed, and it's like, oh, here's a rock. Let's name, that's Addie Dove's rock, and then there's Jim Cooney's 3-centimeter crater or whatever. I mean, it's just like we're seeing all this.
Rock.
He didn't say how big my rock was.
That's right. So anyway, we will post images of the touch and go or the rehearsal of that at Bennu, as well as some of these galaxies and the very, very cool neutrino observatories on all our various media. While Australians probably cringe every time they hear us say it, this has been another episode of Walkabout the Galaxy. If you like this episode of Walkabout the Galaxy, give us 5 stars on Apple Podcasts. Hell, give us 5 stars if you didn't like it, because you have to admit, while you may think you didn't like it, you're still listening. So
good point.
Yep.
Be sure to like us on Facebook to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using #WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Production assistance provided by Diego Rodriguez. Jillian Gloria is Director of Marketing. Thanks to our listeners in Barcelona and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.
Tribbles.
Tribbles?
Tribbles.
I've had tribbles in my head ever since you said the trouble with neutrinos. I was thinking the trouble with tribbles.